Okay, we're going to take some time. We're going to go over Algebra 1B, graphing quadratics in vertex form. Okay, that looks just like the question on the INB. I think it is the question on the INB. All right, so we already found that vertex, right? So the H is positive 4 and the K is negative 2. So we fill in these values. Right? Once we know what that vertex is, we put that in the middle of our table, always. Vertex always goes in the middle. Now let's use symmetry. So y equals 2. I'm going to let x be 3. Then I'm going to simplify. Yep, this is the exact same problem. I remember it now. 2 times 1 minus 2, 0, 0, 0. So this is 6 and this is 6. I remember. All right, there it is. Plot your points. Draw your parabola. 4 comma negative o dose. Right there. 5, 0. Right there. 3, 0. There it is. Dose and a 6. There it is. 6 and a 6. Boom. Make sure that bottom is rounded. And put arrows on the end. Goes up forever. That's a little too pointy right there. All right, little too pointy. So round that. All right, make sure your arrows go on the ends. All right, here we go. Let's do this one. Notice it opened up because A is positive, right? A is greater than 0, so it opened up. Notice here, my A equals negative 1. So this is going to open downtown. So it's nice to know that. So the opposite of positive 2 is negative 2 comma negative 1. That's your vertex. All right, now I'm going to do negativo tres, negativo cuatro, uno, and 0. All right, I'm going to do 0 first. So I have negative. Remember, there's a little imaginary negative 1 there, right? So that gives me negative 1 times 4. That's negative 4 minus 1. That's negative 5. Boom and boom. Love that. Now I'm going to put in negative 1. Square that. That's 1 squared minus 1. That's negative 1 minus 1 is negative 2. Okay, plot those points. Let's do it. Negative 2, negative 1, right there. Negative 3, negative 2, right there. Oh, that's not it. That's it right there. Negative 1, negative 2, boom. 0, negative 5 is the y-intercept. And negative 4, negative 5 is right here. Ooh, boom and boom. It opened down just as we predicted. Just as we predicted. All right, there it is. Notice there's no x-intercepts. So if I was going to ask you for the x-intercepts on here, you would say none. There's always one y-intercept. And there it is. All right, let's do the next one. All right, 2 comma negative 3. Remember, the h is always the opposite of that, right? So the opposite of negative 2 is positive 2. And the vertex always goes in the middle of your tablar. I'm going to put in 0 because I like it. It's easy, right? That's why we like the number 0. It's easy to substitute in and simplify. So it goes like this. Wow, this number's big. So that's negative 12 minus 3. That's negative 15. That's the y-intercept. That's that as well. All right, now I'm going to put in a 1. Negative 3 times 1 minus 2. Square it. Minus 3. That's negative. That's going to be 1. That's negative 3 minus negative 3. That's negative 6. All right, let's do it. 2, negative 3. Notice the increments of 2 on the y-axis. So when I plot this, I'm going to have to go right there in the middle of negative 2 and negative 4. 3, negative 6. That's right here. And right here. 0, negative 15 is in between negative 14 and negative 15. And right there as well. Boom. Boom. All right, that's money. All right, let's turn this over. Again, let's do it. All right, vertex opposite of negative 3 is 3 comma 3. 2, 1, 4, 5. Put in a 4. 4 minus 3. squared plus 3. That's 1 squared plus 3. Notice you don't have an a value, so that means there's an imaginary 1 there, right? So this is going to open up is 4. So my substituting in a 4, I got out of 4. Substitute in a 1, that's this, and that's that. All right, 3, 3. Boom, right, yeah? 2 quattro. Quattro, quattro. 1, 7. And 5, 7. Notice again, this is crazy. There's no x-intercepts. There's a lot of them that have been doing this. So, right, when I ask you for x-intercepts, look at the graph. You can clearly see whether or not there is one, right? There's none. The vertex is above the x-axis and it opens up. No x-intercepts. All right, this time, I'm going to do it different because I roll like that. I'm going to throw this in the graphing calculadora, and I'm going to show you how to do it that way. Go to y equals. I can put this in just the way it sits. X minus 4 squared minus 4. Second graph. I'm going to look at the table. Look at that right there. 4, negative 4. That's my vertex. And I know it because it's the same numbers above and below that y value. So that's my vertex, 4, negative 4. And that matches, right? H is 4, K is negative 4. There's your vertex. All right, now I'm just going to fill in the table from there. 5, 6. 5 is negative 2. 6 is 4. So that means 3, 2. 3 is negative 2. 2 is 4. That's that symmetry that gives us those same outputs as we go equal distance away on the x. 4, negative 4, way down chow. 5, negative 2, 3, negative 2, 2, 4, 6, 4. Boom. Oh, I almost made it. Boom. Goes up forever. All right, that was money. Let's do it again like that. Notice our A is negative, so I know this is going to open downtown. All right, because A is negative 3, so I know it's going to open down. So negative 3, open parentheses, x plus 1 squared plus 3. Now, I know my vertex. There's the graph of it, by the way, just to see it. Boom, we knew it opened down. I know my vertex is negative 1, 3. So when I go to my table, I'm going to look for that right away. There it is right there, negative 1, 3. Negative 2, 0. Negative 3, negative 9. That must mean 0, 0, and 1, negative 9. All right, let's plot those points and draw this parabola. Negative 1, 3. Negative 2, 0, that's a y-intercept. I'm sorry, that's an x-intercept. 0, 0 is a y-intercept and an x-intercept. That's crazy. It's the only time you can have the same x and y-intercept is if it's 0, 0. All right, and then negative 3, negative 9, right there. Open downtown, boom. Open downtown, boom. That is done. Look, it looks like a smiley face. Ah, that's nice. Okay. You be good. Stay strong. I'll see you soon. Keep working hard till the end. All right, bye.